Hello guys, I hope you are doing okay. Today we have this integral. We have the integral from negative infinity to positive infinity of the sine cubed 3x all over x cubed, and of course we have the dx indicating that we are integrating with respect to x. Actually, one of my friends suggested this integral to me and I arrived at some sort of solution that I would like to share with you today. Without further ado, let's just hop right into it. Well, let's call this integral I. And now let's notice that if we substitute negative x for x in this function right here, we're going to get the sine cubed of negative 3x all over negative x cubed. And because sine is a not function, we could just write this negative outside here. And of course the negatives will cancel each other out, and we're going to be left with the same function that we started with. And this indicates that this function is an even function, which means that it is symmetrical about the y-axis. Thus, this integral could be rewritten as twice the integral from 0 to infinity of the sine cubed 3x all over x cubed, and of course we have the dx. And so to evaluate this integral right here, we need to evaluate this one. So let's call this one to be I sub 0. And so now we have I sub 0 equal to the integral from 0 to infinity of sine cubed 3x all over x cubed dx. So what now? How do we continue from here? Well, let's now invoke the Feynman trick. We are going to define I sub 0 of t, some parameter t, and this t will be right here. We'll place it right here inside of the sine function. And what we are going to do now is we are going to take the first derivative with respect to t. So we are going to get I sub 0 or I sub 0 prime of t, which is going to be the derivative with respect to t of the integral from 0 to infinity of the sine cubed 3tx all over x cubed dx. Now we switch up the order of the integration and the differentiation operators, and we're going to get the integral from 0 to infinity of now what? The partial derivative with respect to t, because we have two variables, we have x and t. Of course, we are only differentiating with respect to t, of the same function, which is sine cubed 3tx by x cubed dx. And now let's see. We have 1 by x cubed. 1 by x cubed is treated as a constant, so yeah. Now let's see, what is the derivative of this term right here with respect to t? Well, from the chain rule, we're going to first get 3 sine cubed 3tx. Then what is the derivative of the sine function itself? It's going to be the cosine of 3tx. Then the derivative of what's inside the sine function, which is 3tx with respect to t, so that's going to give us 3x. Of course, we have the dx right here. And so this integral right now could be rewritten as 3 multiplied by 3 is just 9. The integral from 0 to infinity. And now let's see, we have this x cancels out with the part 3 here, so it just becomes x squared. Now we have sine squared 3tx cosine 3tx dx. Now what do we do from here? Well, let's remember that the sine of 2 theta is equal to 2 sine theta cosine theta, and this implies that sine theta cosine theta is equal to half the sine of 2 theta. Nice. So let's apply this formula right here. How are we going to do this? Well, we are going to rewrite sine squared as sine multiplied by sine. So now we have sine 3tx multiplied by cosine 3tx multiplied by sine 3tx. So this is going to give us 9 by 2, because we're going to take out the fraction outside of the integral operator of the integral from 0 to infinity of the sine of 2 multiplied by 3tx, so it's sine 6tx multiplied by sine 3tx all over x cubed, and of course we have the dx. Now, how do we continue from here? Well, now is a good time to recall some of our trigonometric formulas. Let's recall one of the product to sum formulas, which states that the sine of A multiplied by the sine of B is equal to half multiplied by the cosine of A minus B minus the cosine of A plus B. So if we were to apply this formula right here, we would get because of this half will be out, so it's going to be multiplied by 9 by 2, so it's going to be 9 by 4, the integral from 0 to infinity. Now let's see, sine 6tx multiplied by sine 3tx, our 6tx is going to be dA, and our 3tx is going to be dB. So this gives us, this is going to be the integral of cosine 3tx minus the cosine 9tx all over x squared dx. Now is a good time to take the second derivative of I sub 0 of t, of course with respect to t. So we have I double prime of t, or I sub 0 double prime of t, equal to 9 by 4, the integral from 0 to infinity of the partial derivative, of course after switching up the order, of the cosine of 3tx minus the cosine of 9tx all over x squared dx. And so upon taking the derivative, we're going to get 9 by 4, the integral from 0 to infinity of what? Let's see, 1 by x squared is just a constant, so we remove it out. Let's see, what's the derivative of the cosine of 3tx? Well, the derivative of the cosine 3tx is negative sine 3tx multiplied by 3x. And what's the derivative of negative cosine 90x? It's going to be just positive sine x, because the negative will cancel out the other negative. Positive sine 90x multiplied by 9x dx. Nice. And so because we have x here, and x squared here, we could just factor out an x from here and here. So this cancels out with this, and we're just going to be left with 1x to the power of 1 in the denominator. So, and now let's factor out this 3 outside. 9 is just 3 squared, so let's factor out the 3 and remove it out and take it out of the integral operator. So we are going to get 9 multiplied by 9 over 4 multiplied by 3, which is just 27 over 4, the integral from 0 to infinity. And now what? Well, now we're going to have 3 sine 90x minus sine 3tx all over x. And of course, we are integrating with respect to x. So we're going to rewrite this as 27 over 4. I'm going to open up a big bracket. So this is going to be the integral from 0 to infinity. Now we have 3 multiplied by this integral, sine 90x by x dx minus the integral from 0 to infinity of sine 3tx all over x. And of course we have the dx. So how do we continue from here? Well, let's let 90x to be equal to u, and this implies that our x is equal to u by 90, which implies that dx is just going to be du by 90. So now we're going to have 27 by 4 multiplied by 3, the integral. Let's see, as x tends to 0, u is going to tend to 0, and as x tends to infinity, u is also going to tend to infinity. So the limits have not changed. The integral from 0 to infinity of the sine of u all over x, which is just u by 90, and of course our dx has become du by 90. And let's notice that 90 cancels out with 90, and we are just left with the integral of sine u by u, the integral from 0 to infinity of sine u by u, which is of course a pretty popular integral. This integral converges to pi by 2, so that's actually pretty nice. So we could just rewrite this as 3 pi by 2. Well, what about this integral? Well, same case, nothing had changed much. The 9 just became a 3, so if we let 3tx to be u, this will give us that x is equal to u by 3t, which implies that dx is equal to du by 3t, which gives us the integral, the boundaries have not changed, from 0 to infinity of the sine of u over u by 3t, and of course integration with respect to u. Our dx became du over 3t, so the 3t also cancels out with the 3t, and again we are left with the same integral, which converges to pi by 2. So this whole integral just converges to 27 by 4 multiplied by 3 pi by 2 minus pi by 2, which is just 27 pi by 4. And so now what? We have reached that the second derivative of I sub 0 of t is equal to 27 over 4 pi. And now to continue, let's just reintegrate this with respect to t. So we're going to integrate both sides with respect to t. And of course, on integrating I double prime of t, or I sub 0 double prime of t, we're just going to get the first derivative of I sub 0 of t. And here 27 over 4 pi is just a constant, so we're going to get 27 pi over 4t, and of course plus some constant which I'm going to call c1. And now we need to evaluate this constant. So how do we evaluate it? Well, let's just substitute t is equal to 0, and when doing so we're going to get 27 pi over 4 multiplied by 0, which is just 0, plus c1 equal to I sub 0, or the first derivative of I sub 0 of 0. So what is the first derivative of I sub 0 of 0? Well, let's recall that the first derivative of I sub 0 of t is just this integral, and when substituting t is equal to 0, this whole integral becomes a 0. So the whole left hand side of the equation is just a 0, and this implies that c1 is equal to 0, and this solves much of our problems. And now we are going to be left with this one, which we are going to do the same thing that we did. Let's now reintegrate this with respect to t, and when doing so we're going to get I sub 0 of t, which is going to be equal to, now let's see, 27 pi over 4 is just a constant, and the derivative of t is just t squared by 2, so now we have 27 pi over 8 t squared plus some constant, which I'm going to call c2. And now we need to evaluate c2, and let's substitute t is equal to 0, and doing so this term right here becomes 0 plus c2. And what is I sub 0 of 0? Well, if we return to our original integral, we would notice that I sub 0 of t is just this integral, and when placing t or substituting t is equal to 0, this integral becomes just 0. So again, the whole left hand side of the equation is just 0, which implies that c2 is equal to 0. And now let's see. We have evaluated I sub 0 of t to be 27 pi over 8t squared. Well, our original integral was the integral from 0 to infinity of the sine cubed 3x by x cubed dx. So this is just I sub 0 of 1, so we need to substitute t equal to 1, so this is going to equal 27 pi over 8. And let's recall that our very original integral actually was twice this integral, so it's going to equal twice 27 pi over 8, so it's going to be equal to 27 pi over 4, which is pretty nice result actually, because 27 is just 3 power 3, 4 is 2 power 2, and pi is pi, so it's a pretty cool result. I hope you have liked this video. If you enjoyed this video, please like it. If you'd like to see more content like this, please subscribe to the channel, and if you have any suggestions for any problems, drop it in the comments section. And that's it. See ya.